Hello and good morning. My name is Michael Kwestiahat and my metric number is 2551. Today, I would like to present the topic about fluid features and dimensional analysis concepts. I begin from fluid definition first. So fluid is a substance that does not possess a definite shape and easily yields to oxidation pressure. And fluid are divided into liquid and gases. There are four classifications of fluids. First, steady or unsteady. Steady fluid, it is the fluid whose density remains constant at each and every point while flowing. And unsteady fluid, it is the fluid whose velocity differs between any 2 points while flowing. And then there are viscous or non-viscous. Fluids with more thickness or viscosity are known as viscous fluids. They are generally very gloopy fluids. For example, shampoo and motor oil. Fluid with comparatively less thickness or viscosity are known as non-viscous fluids. These are the fluids with no resistance or negligible resistance to internal frictions. Non-viscous fluids flow without any loss of kinetic energy. For example, sulfur fluid, liquid helium. Third, compressible or incompressible. These are classified based on the Mach number. The incompressible fluid has Mach number bigger than 0.3, and the compressible fluid has Mach number between 0.3 and 1. And the last one is rotational or irrotational. If the angle between the two intersecting lines of the boundary of the fluid element changes while moving in the flow is a rotational flow. Depending on the angular motion of the fluid, it is classified into rotational fluid or irrotational fluid. If the fluid rotates as a whole with no change in angle between the boundary lines, the flow of the fluid is classified as a rotational flow. And in fluid, especially in fluid mechanics, there are several properties of fluids. First, density. Density or mass density is a quantitative expression of the amount of mass content per unit volume. And this the formula of density. Density equals mass per volume, and the international unit density is kilogram the power of -3. Second, specific weight. The specific weight, also known as the unit weight, is the weight per unit volume of material. Commonly used value in the specific weight of water on Earth at 4 degrees Celsius, which is 9.81 kilonewton per meter cube, or 62.4 uh, pound force per feet cube. In fluid mechanics, specific weight represents the force exerted by gravity on a unit volume of a fluid. Third, specific gravity. Specific gravity is defined as the ratio of the density of fluid to the density of standard fluid. For liquids, water is taken as the standard fluid, whereas for gases, air is taken as the standard fluid. For temperature, temperature is one of the thermodynamics property of fluids that determines the state of hotness or coolness of it. Temperature is measured in either Kelvin or Celsius or Fahrenheit, but Kelvin is the most common on that use because of its independence from the property of the substance. And the following graph really depicts the effect of temperature of fluids. Fifth, pressure. In fluid gases and liquids, we speak of pressure. In solids, this is normal stress. For a fluid at rest, the pressure at a given point is the same in all directions. Differences or gradients in pressure drive a fluid flow, especially in ducts and pipes. And then there are viscosity. The viscosity of a fluid is a measure of its resistance to deformation at a given rate. For liquids, it corresponds to the informal concept of thickness. For example, that syrup has a higher viscosity than water. Surface tension. The cohesive force between liquid molecules are responsible for the phenomenon known as surface tensions. The molecules at the surface do not have other like molecules on all sides of them, and consequently, they cohere more strongly to those directly associated with them on the surface. Surface tensions as dimension of force per unit length or Newton over meter or of energy per unit area or joule over meter cube. And the last one, vapor pressure. Vapor pressure is the pressure at which a liquid boils and is in equilibrium with its own vapor. And when the liquid pressure is dropped below the vapor pressure due to a flow phenomenon, we call it as process cavitation. Basically, I already explained about fluid properties. There are several types of fluids. There are four types of fluids. First, ideal fluid, and the fluid which is non-viscous or frictionless and incompressible is called ideal fluid. We assume that ideal fluid is perfect fluid, but fluid without viscosity is not possible or doesn't exist in real world. So this is only imaginary fluid. Second is real fluid. All fluids comes under real fluid because all the fluid having viscosity, compression, and surface tension in its property with a little amount of force. For example, there are water, petrol, and air. Four is Newtonian fluid. The fluid which is obey the Newton law of viscosity. And Newtonian fluid have constant viscosity and it doesn't depend upon the shear stress applied on it. For example, is kerosene. And the last one, non-Newtonian fluid, which is the fluid which doesn't follow Newton law of viscosity and relationship is depend upon all the three quantities: shear stress, viscosity, and velocity gradient. For example, of non-Newtonian fluid is blood, paint, and ink. We enter dimensional analysis concept. Dimensional analysis concept is mean of simplifying a physical problem by appealing to dimensional to reduce the number of relevant variable and help of dimension and units of measurements. There are several benefits of dimensional analysis, especially application in engineering, like to check the consistency of dimensional equation, to derive the relationship between physical quantities and physical phenomena, and to change units from one system to another. In dimensional analysis concept, there are fundamental dimension and the rough unit. Fundamental dimension, the quantities they are not dependent on some other quantities are called fundamental quantities. And the unit which are basically used to measure these quantities are known as fundamental units. And this system of unit can be further classified as International System Unit, CGS or centimeter gram second system of unit, MKS, meter kilogram and the second, and FPS, frames per minute. And then the quantity which are dependent on the fundamental quantities for the existence such types of quantity are called derived quantities, and the unit which are used to measure such type of quantities are known as the derived unit. In dimensional analysis concept, there are two types of dimensional. First, dimensional homogeneity and dimensionless. Dimensional homogeneity is a rule that determines how equations are formulated. It states that the dimension or units of each term is a dimensional equations on both sides of the equation should be the same. This means the dimensions of the terms that are added or subtract must be the same, and the dimension of the right side of the equation must be the same as those of the left side. As a simple example, consider the Margulis equation for evaluating fluid viscosity from experimental measurement. And based on this formula, this formula is dimensional homogeneous since both sides of the equation have dimensions length over -1 times mass times power of -1. And the last one is dimensionless. Dimensionless number in many fields of engineering are a collection of variables that provide order of magnitude estimates about the behavior of a system. They are often derived by combining coefficients from the differential equation and are oftentimes a ratio between two physical quantities. And for example, by this formula, this is the dimensionless parameter describing flow include boiling is called cavitation formula, which PA is ambient pressure, PV is vapor pressure, rho is density, and V is the fluid of velocity. And I think that's all from me. Thank you very much for your listening.